Okay, for 7103, they're giving us a table of data, and before you start to answer questions, you really need to understand what the data is. So it says Marissa's older sister was discussing purchasing a car. Marissa collected data from her friends at her job. So the table is the age of the car, like how many years old it is, and the miles per gallon for that car. So clearly they're trying to see if there's any relationship between older cars and how many miles per gallon you get. Clearly you want more miles per gallon, right? You want better gas mileage. So A says Marissa wants to know the typical age of her friend's cars. So like the most common ages. When you're trying to find out like common ages or how things are grouped together, typically a box and whisker is going to do that. Remember, because it breaks it into quartiles, right? A typical box and whisker, right, looks like this, right? And you could then see, right, that everything is shifted up to the right. You can find information about groupings and things like that. So for A, I'd say a box plot or a box and whisker works the best. For B, it says she wants to convince her dad that newer cars are more fuel efficient. Newer cars are more fuel efficient. So now she wants to find a correlation between this data. To find a correlation between this data, a scatter plot is going to work the best, right? Because, if you have something like this, then you could show, that as the age of the car increases, the miles per gallon decreases, something like that. As the age of the car decreases, the miles per gallon increases. You want to find a correlation. So B would be a scatter plot. Now next, they want us to make a scatter plot. So I'm going to take a shortcut here, right? I am going to bring up the scatter plot because, one, it's really hard to graph on with a stylus. So here's the scatter plot after you just graph those points, right? So they're trying to determine if the miles per gallon is dependent on the age of the cars, right? So we drew the scatter plot, and then we draw a trend line in the scatter plot. And clearly you should have your axes drawn and things like that. But okay. So now, right, this is really the y-axis, right? And this is the x-axis, right? This would look like this typically. Right. Okay. So now they said, what's the association? So it's a negative correlation, right? Because it's going downhill. As one increases, the other decreases. And I'm fine with that as an association. I would say it's, as the book, there's strong and weak. I would say it's weak because the points aren't tightly coupled, but I'm fine if you say it's a negative correlation. So next they want us to find the equation of the line. So let me make some space here. Let me bring this up here. And remember, it's y equals mx plus b is slope-intercept form. M is the slope, right? And b is the y-intercept. So we can look on our graph to find the y-intercept, right? Right there is the y-intercept. So I'd say that's 36. So I'm going to say that's 36. Now to calculate the slope, we want to find 2 points, preferably, that are right on the intersections of this grid. And I can find 2 points like that, right? And let me get rid of this one. I can find this point right here, and I could find another one, let's see, right here. Let me see as I go down. This one is reasonably close, so I'm going to say that that's, on that intersection. So let's draw our slope triangle from those 2 points. So I'm going to do it in red. So I need to go down this much, right? And then over. And I'm going to try to draw this as good as I can here. So remember, I'm going from here to here, right? Okay. So when I go, if I start at this point, right, if I'm going to make this my starting point, I go down from 35 to 30. So that's -5, right, down. And then I go across to the right, 1, 2, 3, 4, 5, 6, 7. So this is +7 because it went to the right. So the slope now, based on this, is down 5, -5 over 7, right? So the slope is negative 5/7. So now I know the slope, right, negative 5/7, and the y-intercept. So I get y equals negative 5/7 x plus 36 as the equation of the line. And the book actually got 0.7, negative 0.7, which would be 7/10, right? We're close, right? And this is true with trend lines. With trend lines, you're going to have slightly different answers for your problems. So now it says estimate it when it's, let me see, estimate, I don't have the original question, so let me look at it now. Now it says use the equation to predict the correct mileage for a 7-year-old car. It's not really the correct mileage, it's your prediction based on your line of best fit. So for a 7-year-old car, so they're saying insert a 7 for the X, right? And, right, so this is the equation of the line of best fit. Insert a 7, right, for that, for X, and see what Y comes out to be. So this would be, right, this cancels, negative 5 plus 36. So Y equals 31. So that would mean the answer would be 31 miles per gallon, right? Miles per gallon. Right? 31 miles per gallon, or 31 mpg, right? For part G, they're saying to analyze or determine what the slope means and what the y-intercept means. Okay, so let's get rid of this for a second. So the slope really means that for every change, right, for every change in 1 year, right, because that's every change in 1 year, we're going to go, the miles per gallon is going to decrease by 5/7 of a gallon. So the slope really means for each year, the miles per gallon will reduce, because it's negative, right? Reduce 5/7 of a gallon in miles per gallon, right? In miles per gallon, which is pretty substantial. That's almost a gallon, right? Each year. Okay, so that's the slope. The y-intercept, remember the y-intercept is here. The y-intercept means that a car that's 0 years old, but we don't say a car that's 0 years old, we say a new car, right? A new car will, get 36 miles per gallon. Right? Clearly a little outdated. We probably get better than that now. But that's what those two mean.